Hi, good morning everyone. My name is M. Sheshgiri, EEE Department, Vardhaman College of Engineering. This is Electrical Machines 1 lab. In this lab, we are going to perform the experiment on a DC shunt identical motor generator set. So for that, I have taken this motor generator set, and the advantage of this particular test is we can calculate motor efficiency as well as generator efficiency at a time by conducting this experiment, named as back-to-back test, because we have a connection between motor and generator. Input DC supply and output to generated DC supply, both are connected to each other. So we are connecting meters at motor side as well as generator side. We are taking motor side's meters, ammeter reading, voltmeter reading, and we are noting down armature currents, line currents and field currents. And generator side also we are taking armature current, line, field current. So separately we are calculating the losses, and separately we are calculating efficiency of motor and generator side. This test also referred as regenerative test, and in this particular test we are finding out the efficiencies of motor and generator. The accuracy of the efficiency will be more, and high rated machines can be tested by this experiment. So let us see the circuit diagram. So I would like to explain the circuit diagram briefly. We have a connection for motor side, we have a connection for generator side. Both are identical motors. The condition for conducting this test is identical machines are required. So here we have connected an ammeter in the line and another ammeter in the field winding. Generally, field ammeter is rated for 0 to 2 amps DC. Line ammeter is rated for 0 to 10 amps DC. And a voltmeter is connected parallelly with the power supply. And there is a switch between motor and generator side. Electrical connection we are connecting through a switch, and mechanically it is coupled. The motor is coupled to armature mechanically, but the electrical connection through switch we will make, because we need to test the incoming voltages from the input power supply, and the generated voltage from the generated power supply should match with each other. The equal and the opposite voltages meeting at a point becomes zero. Thus can be known by a voltmeter connected across switch, because the switch is in between generated voltage and input voltage. If both are same only, we are supposed to close the switch. So for that testing, we have connected voltage across switch, and after closing the switch, when these voltages matching with each other, that known by this voltmeter when it shows zero. If anything voltmeter deflects, means the voltage proportions are not equal. So we should test for the zero deflection in the voltmeter. Then only you are supposed to switch off the switch and allow the current to flow through the generator. And here we are connecting an ammeter in the line and another ammeter in the field connections. We are taking separately of this ammeter reading and this ammeter reading. So after closing the switch, so we are getting separate readings for motor, separate readings for generator, and after that we are calculating the losses at motor side, losses at generator side. With that we are calculating efficiency individually for motor and generator. So in the connection part, so I have selected this voltmeter. These two are the motor side meters, and remaining all these two are the motor generator side meters, and a voltmeter is connected across switch, and a line ammeter, and one more ammeter is taken at the field side. So see the circuit diagram, follow this. So first we will connect a voltmeter across power supply to read how much voltage we are giving as input. So I will take a short wire which is suited for voltmeter, and a voltmeter is parallelly connected with the power supply plus. So voltmeter is connected across power supply, but the leaving terminals from the rheostat, one connection will go to Z and other connection will go to, the 100/5 will go to armature, 400/1.7 will go to Z. From the power supply, we will connect through an ammeter line to measure line current, how much line current it is taking. So I'll take an ammeter in series with line. So I'll connect it to ammeter. The second end of the ammeter is taken as input to the rheostats. These two are joined and given at the second end of the 400 by 1.6 is connected to magnetic field coil, and one more ammeter is taken 0 to or 2 amps. So this 1 ampere meter is taken from ZZ terminal, and this negative of the ammeter is taken to negative of the power supply like this. And AA armature connection also taken to negative. Here it is, we will connect at this point. So now the motor side connections are over. When coming to generator, we have a gap between this motor A to generator A. We will connect the switch across this A and this A. Simple connection. And from this A, I will take a connection, connect it to switch, because we need to check the amounts of the voltages which is coming as input from the motor side and generated voltage matching with each other. Then only you are supposed to close the switch. So for that reason, I am connecting this SPST switch across motor A and generator A. And here the output of the switch is taken through an ammeter. Output of the switch is taken through an ammeter which rated for 10. Yeah, this is the ammeter, and the ammeter output is taken to, so generator side A which is going to this switch is taken through ammeter. First I will take to ammeter 0 to 10 amps, and the other terminal of the switch nunchi vastundi. A is connected to, switch is connected to ammeter, output of switch is connected to ammeter. Ammeter other terminal is taken to A. So like this. So whatever the line current drawn by the generator is shown by this meter. So this meter is connected, and after this A is taken to rheostat. One more rheostat which is rated for 600 by 1.7, because the excitation current of the generator will be very less, 0.48. So I have selected 600 by 1.7 here. So I'll put it as conveniently like this, and one rheostat terminal is connected to ammeter, or which is going to ammeter, or here also you can connect, and the other terminal of the rheostat is taken to Z of the generator, and then generator ZZ is connected to 0 to 2 amps ammeter, and the other terminal of the ammeter is taken to AA. And one more thing you have to observe is, we have connection between motor AA to generator AA like this. Both way you have to short. So motor AA is here. It is connected to generator AA to motor AA is joined. See. So like this, you have to join generator AA with motor AA. These are the connections of the Hopkinson test, and keeping the armature rheostat at maximum position, keeping the field rheostat at minimum position. Rheostat which is connected in between the armature terminals of the generator and field terminals of the generator should kept at maximum position. Now this voltmeter is connected across with power supply to see whether deflection shows 0 or not. When this shows 0 means the input voltage which is coming from motor and the generated voltage which is coming from generator side, both will match with each other. Then only the deflection of the voltmeter will show 0. When this shows 0, you are supposed to close the switch. So for that I have connected positive at one end of the switch, negative at the other end of the switch like this. This voltmeter you need to observe. These are the connections. Generally we treat odd numbers of the meters at generator side, even numbers of the meters at motor side. Motor side meters are named as I2 current and I4 current, which is going from line of the motor and flowing through the field terminals as well as armature terminals, named as I4. So I2, I4. Odd numbers of meters at generator side, the field ammeter as well as line ammeter which is connected here is named as I1 and I3. After noting down I2, I4, I1, I3, we will calculate the efficiency of the motor by calculating the losses at motor side and the calculating losses at generator side. That is the procedure. Let us see. After switching on, we will try to observe the meters reading. Now MCB is switched on to upwards and the power switch is on. So let us bring the speed of the motor to rated speed by varying the armature rheostat. To the 1500 rated speed. This voltmeter is showing the input voltage which is coming from the motor, as we have a connection between motor terminals, and start decreasing the rheostat which is connected to generator side field, and observe the reading going to zero position. See, voltage is going to zero position. That means generated EMF opposing the input voltage of the motor. That is to be done. So when it becomes zero position, now it is exactly zero position. That means both the voltages meeting at a point cancels each other and it has become to zero position. Now you are supposed to close the switch. Now I have closed the switch. You can see the switch position. Switch is closed. So it is operated under regenerative mode, and we will carry out the readings. Voltage, this is I2, this is I4, and this reading is I3, I1. After taking all the readings, we will calculate the efficiency of motor and generator individually. So this is the test. So after that, open the switch, decrease the voltage generated by the generator, and bring the speed of the motor to initial position by decreasing the armature resistance. Switch off the equipment. Thank you.